Hello children, once again welcome back to Physics with Sanoop, Hailing Medical Aspirations. See, in this video we will be discussing the past questions from the chapter Newton's Laws of Motion. See, this is a very important chapter, so you can expect 2 to 3 questions from this chapter for NEET. Okay, let's go to the questions. First, a football player is moving southward and suddenly turns east with the same speed to avoid an opponent. The force that acts on the player while turning is. See, acceleration is final velocity minus initial velocity. Suddenly he turns eastward. Okay, so the final velocity is directed due east, right? East. Okay, see, this is due north, okay, and this is due south. This will be due east. This is the direction of his final velocity, and this is due west. Okay, how do we find the change in velocity? Final velocity minus initial velocity. Final velocity is directed due east. Okay, so see, this is the final velocity, V2. V2 I have drawn first. Okay, V2. Now, see, to find V2 minus V1, we will have to add negative of V1 with V2. We have to find the resultant of V2 and minus V1. Okay, what is V1? Means initial velocity. See, football player is moving southward, so the initial velocity is directed south. Okay, due south. So minus V1 will be due north. Okay, so first I have drawn this V2. Okay, first I have drawn this V2, then minus V1 should be drawn on the tip of V2. Okay, V1 is due south, so minus V1 should be due north. Okay, so this is minus V1. Okay, now I have to find V2. See the resultant of V2 and minus V1. So first I have to draw V2, then minus V1 should be drawn on the tip of V2. Okay, then the vector drawn from the tail of the first vector to the tip of the second will give you the resultants. Okay, so this is V2 plus minus V1 or V2 minus V1, or that is the change in velocity. See, acceleration will be along the direction of change in velocity. So the force also will be along the direction of change in velocity. Okay, so this is the direction of change in velocity, and see this angle, suppose it is theta, then what is tan theta? Opposite side V1 and adjacent side V2 are of equal magnitudes. So tan theta is 1 and theta is 45. So the direction along which he experiences a force must be equally inclined to north and east. It's called northeast or east-north. Okay, northeast or east-north. So along northeast, that is the correct option. Okay, now let's go to the next question. A ball of mass 0.15 kilogram, means it must be 150 gram, is dropped from a height of 10 meter, strikes the ground and rebounds to the same height. Rebounds to the same height means see, it must be rebounding with the same speed with which it strikes, then only it will go up to the initial height. Okay, the magnitude of impulse imparted to the ball is equal to the change in momentum. Okay, and see, initially it is released from a height of 10 meter. So the speed with which it strikes the floor will be, that is V1. Okay, V1 must be equal to root of 2gh. 2 into g is 9.8 and height is given as 10 meters, so it will be 14 meter per second, and it bounds with the same speeds. Okay, so V1 like this, and V2, oh my god, both V1 and V2 here marked in the same direction. Okay, so let me correct this, that see, first this one. Okay, V1 directed down and V2 directed up. Okay, so right. Okay, this is V1 and see, this is V2, right? Let me take the upward direction, that V2 as positive, and downward direction V1 as negative. Okay, so both will be of equal magnitude, that is equal to 14 meter per second that we have got, and mass is 0.15 kilogram. So V2 minus V1 will be, or the impulse is equal to, see, impulse, this is equal to change in linear momentum. That is equal to mass into change in linear velocity. Mass is 0.15 kilogram, and change in velocity is final minus initial. Final directed upward, that I have taken positive. Initial directed downward, so it should be negative, so minus 14. Okay, that is 28 into 0.15. Okay, 28 into 0.15 will give you 4.2 kilogram meter second raised minus 1. 4.2 kilogram meter per second. Okay, we have force plotted against time, and what we have to find out, the change in momentum of the particle, that is equal to impulse. How do we find the impulse? See, in any graph you will have to find out two things. What is the physical quantity represented by the area under the graph? It is nothing but y into x, means quantity along the y-axis into quantity along the x-axis. Here we have force along the y-axis and time along the x-axis. So area under this graph will give you force into time. It is the impulse, and it is equal to change in linear momentum. Okay, so we have to find the change in linear momentum or impulse or the area under the force time graph from 0 to 8 seconds. Here is we have 0 time, and here we have 8 seconds. Okay, so we have to find the area under this graph. See, the first part is a triangle, and the area is half into base into altitude. So half base is how much? That is 2 units, and altitude is 6 units. Okay, the second one is a rectangle. Okay, see, its length is from 2 to 4. And its see, height that is minus 3 units, so it will be 2 into minus 3. And the third part is also a rectangle. Its length is from 4 to 8, means 4 units length and 3 units height, so it will be 4 into 3, that will give you 12. This will give you minus 6, and here again 6, so it will be 12 Newton second. Okay, 12 Newton second means the option C, right? Okay, a body of mass m is normally, m hits normally a rigid wall with a velocity v and bounces back with the same velocity. The impulse experienced by the body is, okay, see, impulse is change in linear momentum as it reverses its direction without changing its magnitude. So the velocity final, let us take, see, this is initial velocity directed towards left, let's take it minus v. Okay, then the final velocity that will be directed towards right, and let us take it plus v. Okay, so change in velocity will be v minus v, so that is 2v and 2mv. 2mv. Okay, so this must be the correct option. Let's go to the next question. A body under the action of a force, it is given in component form, okay, and occurs an acceleration of 1 meter per second square. What is the mass? See, mass equals force by acceleration. Acceleration we have 1 meter per second square, so the mass will be equal to the magnitude of the force. We have the force in component form, so now you have to simply find the magnitude of this force. It will be under root. Okay, 6 square minus 8 square plus 10 square. Okay, 6 square plus 8 square is 10 square, so 10 square plus 10 square under root, so it will be 10 root 2 Newton. Okay, that is the force, and the magnitude of acceleration is 1 meter per second square, so the mass will be 10 root 2 kilogram. So 10 root 2 kilogram, this much. Okay, 0.5 kilogram ball moving with a speed of 12 meter per second strikes a hard wall at an angle 30 degree. It is reflected with the same speed at the same angle. Fine. If the ball is in contact with the wall for 0.25 seconds, the average force acting on the wall is. See, force will be change in momentum divided by time. So this is the initial linear momentum, and this is the final linear momentum. So we have got linear momentum of equal magnitude. Inclined at an angle, see this much is the angle and it is 60 degree. Okay, 60 degree. Okay, so we have two vectors of equal magnitude inclined at an angle 60 degree. Okay, if we have two vectors of equal magnitude, if we have two vectors of equal magnitude, children, this is very important. We have two vectors of equal magnitude, each equal to p, inclined at an angle theta. Okay, then the magnitude of the vector resultant, it is 2p cos theta by 2, r resultant, and the magnitude of the vector difference, it is 2p sin theta by 2. Okay, here we have to find the change in linear momentum. So we have to find the vector difference. It is 2p sin theta by 2. Okay, 2p sin theta by 2, where p is the magnitude of either vector. Okay, so it will be 2v sin theta by 2. Theta we have got 60. So sin 60 by 2, that is sin 30, and it is equal to, sin 30 is 1 by 2. So it will be 12 meter per second change in velocity. Okay, the force is mass times change in velocity divided by time. Time is 0.25 seconds and it can be beautifully expressed as 1 by 4. Okay, so it will be 0.5 into 12. This 4 will go to the numerator. 4 into 0.5, that is 2 into 12 will give you 24 Newton. Okay, so this one 24 Newton. Okay, so let's go to the next question. That is, a cricketer catches a ball of 150 gram. Okay, with a velocity 20 meter per second, then experiences a force of, okay, time taken to complete the catch. See, when a cricketer catches a ball, he will be drawing his hand backwards, okay, by slowing down the ball. Okay, so the time taken by the cricketer to stop the ball, here it is given as 0.1 second. 0.1 second. Okay, so the force is mass, change in velocity divided by time. Final velocity is 0 and initial velocity it's given as 20 meter per second. Means it is 72 kilometer per hour. Okay, so 150 gram can be expressed as 0.15 kilogram into 20 over 0.1. That is 1.5 into 20 or 2 into 15, that is 30 Newton. So the option must be B. A 5000 kilogram rocket is set for vertical firing. The exhaust speed is 800 meter per second. To give an initial upward acceleration 20 meter second response to the amount of gas ejected per second to apply the needed thrust will be. See, the thrust on the rocket will be V into dm by dt. The force acting upward is V into dm by dt. Force acting downward will be weight of the rocket. So the resultant force acting upward means upward force minus downward force. Means V into dm by dt upward minus mg, that is the resultant force acting upward. Means this stands for F. It must be equal to ma. F equal to ma. So V into dm by dt will be m into g plus a. Okay, and dm by dt will be m into g plus a over v. Mass is 5000, g is 10, and acceleration is 20, and velocity is 800. So we will get 375 divided by 2, and it is equal to 375 divided by 2 must be 187.5 kilogram second raised minus 1. Okay. In the diagram shown, the normal reaction force between 2 kilogram and 1 kilogram is 2 kilogram and 1 kilogram is. See, all the surfaces are assumed to be frictionless. Okay, here we have 3 kilogram, 2 kilogram and 1 kilogram. So the total will be 6 kilogram and its weight will be acting. So the component along this direction will be mg sin theta. Mg sin theta. See, here we have mg. So this will be mg cos theta and this will be mg sin theta. Normal reaction acting will be acting like this. Okay, so here we have a total of 6 kilogram. So the component along this direction will be mg sin 30. Okay, so 6 into g is 10, sin 30 is half, so it will be 30 Newton. Okay, so the resultant force acting down the incline, see, component of weight 30 Newton and the force applied here is 18 Newton. So the resultant force down the inclined plane will be 18 plus 30, that will be 48. The force acting up the incline is 60 Newton. So the resultant force will be 60 minus 48, that is 12 Newton acting up the inclined plane. 12 Newton acting up the inclined plane. Okay, so the acceleration will be, see, this is, that is equal to 12 Newton divided by total 6 kilograms. So it will be 2 meters second raised minus 2 acting up the incline. Okay, or the acceleration of all the blocks will be 2 meter per second square up the incline. Now we have to find the force, normal reaction force between 2 kilogram and 1 kilogram. Means we have to find the force at this interface. So for that, you split the system at that interface. Okay, let's consider the 1 kilogram mass alone. Okay, see, this 1 kilogram mass will exert a force on 2 kilogram. Then 2 kilogram will exert an equal reaction on 1 kilogram. And that force we have to find out. Let it be small f. Okay, that small f will be exerted by 2 kilogram on 1 kilogram. See, along the incline upwards. It is represented by small f here. Okay, the force, external force acting on 1 kilogram will be 18 Newton down the plane. Okay, any other force? Of course, the component of the weight, that will be mg sin 30 like this. Mass is 1 kilogram, g is 10 and sin theta is half sin 30. So that will be equal to 5 Newton. So let's see. All the bodies will be moving up the plane with an acceleration that is equal to 2 meter per second square. This 1 kilogram also will be moving up the incline with the same acceleration 2 meter per second square. So the resultant force on this 1 kilogram must be up the incline. Okay, see what would be the resultant force up the incline? This F minus this will be equal to, see, this is equal to 5. Okay, component of the weight is 5, the external force is 18. So the total force on the body down the incline is 18 plus 5, that is 23. Okay, so F minus 23 is the resultant force acting up the incline. F minus 23, that must be equal to, see, this stands for resultant force. In F equal to ma, F, okay, acting up the incline. That must be equal to mass into acceleration. All the 3 blocks are moving with the same acceleration, that is 2. Okay, so 1 into 2. So F we will get 25 Newton, right? Now let's see the next question. 3 blocks A, B and C of masses 4 kilogram, 2 kilogram and 1 kilogram respectively are in contact on a frictionless horizontal surface as shown. If a force of 14 Newton is applied on the 4 kilogram block, then the contact force between A and B is. See, first let us consider all the 3 blocks together as a system. So the only external force acting on it is the applied force 14 Newton. Okay, so the acceleration of the system will be, see, the external force F divided by total mass, that will be 2 meter per second square. So all the 3 blocks will be moving horizontally with the same acceleration, that is equal to 2 meter per second square. And capital F is that is equal to 40 Newton. It is the only external force acting on the system along the horizontal. Okay, there is no other horizontal force acting on it. Now we have to find the contact force between A and B. Okay, see, wherever we want to find the contact force, we have to split the system at that interface. Here we have to find the force between A and B. So let's split the system at that interface A and B. Suppose F is the force, small f is the force exerted by A on B, that is to be determined. Then B will exert an equal reaction on A. Let that force be small f. Okay, so now let us consider that block A alone as a system. Block A alone as a system. So anything other than the block A will be outside the system, okay, or external. Okay, now see, when we draw the free body diagram FBD for the block A, the forces acting on it are the applied force 40 Newton acting towards right. Now the reaction exerted by the block B, on the block A that is acting towards left, that is represented by small f, that we have to determine. See, all the blocks are moving with the same acceleration, that is 2. Okay, now let's apply F equal to ma, the beautiful, wonderful formula from, or it is the mathematical form of the Newton's second law of motion. That F stands for the resultant force. What is the resultant force on this block of mass 4 kilogram? 14 Newton towards right, small f towards left. So the result, see, the whole system is moving towards right. So the block A is also moving towards right. So its resultant force must be towards right. So the force acting towards right must be stronger than the force acting towards left. Okay, so 14 must be stronger than small f. So the resultant force will be 14 minus f. In F equal to ma, see, this stands for F equal to mass of the body into acceleration. Okay, so we will get this one 14. See, 14 equal to right. 14 equal. Sorry, we will get 14 minus F equal to 4 into 2. Okay, so F will be 14 minus 8, that is equal to 6 Newton. Okay, now see, the same force we can find out by considering the other two blocks as a system. Okay, now let's consider this 2 kilogram and 1 kilogram block together as the system. So the force acting between these two blocks will be internal force. Okay, that we will not consider, that we should not consider while writing F equal to ma. In F equal to ma, F is the resultant external force. Okay, so when these two blocks together is considered as the system, anything other than these two blocks will be outside the system or external. So A is outside the system. So the force exerted by A on this combination will be an external force, and it is the only external force acting on this system along the horizontal. Let it be small f. Okay, and that f we have to find out. This is the resultant force equals mass into acceleration. Mass we have 2 plus 1, 3, and acceleration is 2. So again we will get 6 Newton. Okay, children, now we have another question based on a wonderful concept. Okay, see, when we keep a body on the floor of a lift which is moving in vertical direction, then its apparent weight will be m into g plus a when the lift accelerates upwards, and m into g minus a when the lift is going down. Okay, when the lift is going down with an acceleration a. Okay, see, this apparent weight, please listen, apparent weight means the force with which the block presses on the floor of the lift. Then the lift will exert an equal reaction on the block in the upward direction. So m into g plus a is the force exerted by the floor of the lift on a block in the upward direction. So m into g plus a acts upwards and mg acts downwards. So the resultant force will be ma, and it is acting upwards. That is why the block is moving with an acceleration a, because the lift itself is moving up with an acceleration a. So when the lift goes up, the force acting on the block in the upward direction must be stronger than the force acting downward. That is the weight mg. When the lift is going down with an acceleration a, the downward force on the block, that is its weight, must be stronger because it is going down than the force acting on it. So the force acting on it will be m into g minus a, and the force acting down will be mg. So the resultant force will be downwards. It will be mg minus m into g minus a. That is ma. That is why it is going down with an acceleration a. Okay, please listen, please listen, please listen. See, block. Okay, see, when it goes up, okay, when it goes up with an acceleration, see, it is going up, moves up. Okay, weight mg will be acting, and the force acting upward will be g plus a into m. Okay, so the resultant force is directed upwards, that is why it is going up. Okay, so this upward force is the reaction exerted by the floor of the lift. Means with that much force the body presses on the floor of the lift, or it is the apparent weight. So apparent weight will be more than its actual weight. When it goes down, see, when this body goes down, okay, when this body goes down, okay, so the upward force must be, see, the resultant force must be down, right? Okay, when it goes down, resultant force must be down. So the downward force must be stronger than the upward force, stronger than the reaction, stronger than the apparent weight. Okay, so the apparent weight in this case is m into g minus a. Okay, that is the reaction exerted by the floor. Means with that much force body presses on the floor, or it is the apparent weight. It is smaller than the actual weight mg. Okay, this is the case. See, this is not the case in which this concept can be applied. There are many other cases. Suppose a stone is being lifted by means of a string. The tension in the string is m into g plus a. When a stone is being lowered by means of a string, then the tension in the string is m into g minus a. See, tension is the force acting on the block in the upward direction. See, this reaction is the force acting on the block in the upward direction. So that m into g plus a or m into g minus a is the force on the body in the upward direction. Okay. Now suppose a rope is hung from a rigid support, and suppose a fireman climbs up along the rope with a constant acceleration a. Then the force exerted by the man on the rope is m into g plus a. Force exerted by the rope on the man is m into g plus a. Okay, when he slips down along the rope, the force exerted by the man on the rope or the force exerted by the rope on the man, m into g minus a. Similarly, suppose a hot air balloon, when it ascends, the upthrust, that is the force acting on the balloon in the upward direction. Okay, it will be m into g plus a if it moves with acceleration a, and it will be m into g minus a when it goes down with constant acceleration a. So this can be applied whenever a body is moving in the vertical direction. Okay, with some acceleration upward or downward. Now we have a wonderful question. A balloon with mass m is descending, going down with an acceleration a that is definitely less than g. How much mass should be removed from it so that it starts moving up with the same acceleration a? Okay, so when it goes down, upthrust is m into g minus a, that we have m into g minus a. Now see, some mass is removed. Suppose delta m is removed. Okay, suppose from the hot air balloon some object is thrown out. Okay, so the upthrust, that is equal to the weight of air displaced, that will remain unchanged. See, from the basket something is thrown out. So the volume of air displaced or the weight of air displaced, that remains unchanged. So the upthrust is same as before, but the mass is now got reduced by delta m. The system started moving up with an acceleration a. So the upthrust will be, mass is m minus delta m. As it goes up with the same acceleration, g plus a. Okay, now the question is what fraction? See how much mass should be removed. We have to find, the mass, delta m. Okay, here we have m minus delta m divided by m, that is equal to g minus a divided by g plus a. This delta m we have to find out. See, for that we can use the beautiful procedure, method, that is the component or dividend or rule. Okay, suppose, see, if if x by y equal to a by b, if x by y equal to a by b, then see x minus y divided by x plus y. See, whatever we have done on the left side, same thing should be done on the right side also. A minus b divided by a plus b. Okay, you can do, see, this also, x by x minus y equals a by a minus b, or y by x plus y will be b by a plus b. Whatever you do on the left side, same thing should be done on the right side also. Okay, yeah, here x plus y divided by y equal to a plus b divided by b. Okay children, now what we want delta m. How do we get delta m from here? Please listen. See, if we subtract numerator from the denominator, what do we get? Numerator from the denominator. So m minus m will get cancelled. Then 0 minus delta m will be delta m. So denominator minus numerator I have put on the numerator. On the right side also, denominator minus numerator. G minus g will get cancelled. A minus a will be 2a. That on the numerator on the right sides. Now in the denominator, you keep the denominator as it is. Okay, on the right side also keep the denominator as it is. Okay, now I have got delta m equal to 2a divided by g plus a into m. 2a divided by g plus a into m. So this is the right answer. Okay, next, the coefficient of static friction between blocks A and A of mass 2 kilogram, and the table as shown in figure is 0.2. Okay, what would be the maximum mass value of block B so that the two blocks do not move? The string and the pulley are assumed to be smooth and massless. Okay, see, when the system is released, if the system moves, it will be moving like this. If it moves, it will be moving like this. So the motion, the force that favors the motion will be the weight of this hanging block, and the force that opposes the motion will be the friction over the horizontal surface. Okay, this friction will be mu into weight of this block. That mu is given as see 0.2, mass is 2 kilogram, g is 10. See 0.2 into 2 into 0.2 into 2 into 10. Okay, so it will be, that is equal to, see mu mg. Mu mg is the maximum friction. Okay, mg is the weight of the hanging block. For the system to be in equilibrium or in static equilibrium, for the system to be at rest, okay, this driving force must be less than or equal to the maximum friction. So mg must be less than or equal to mu capital Mg. Right? So we will get m less than or equal to 0.4 kilogram, means it cannot be greater than 0.4. See, m can be either less than or equal to, means it cannot be greater than 0.4. So 0.4 is the maximum value. See, the what would be the maximum? That is 0.4 kilogram, right? A monkey of mass 20 kilogram is holding a vertical rope. The rope will not break when a mass of 25 kilogram is suspended from it. Means the breaking strength of the rope is 25 kilogram weight. 25 kilogram weight means weight of 25 kilogram. Means 25 into g. Okay, that is the breaking strength. So the tension in the rope should be less than or equal to 25 g. When it exceeds 25 g, it will break. Okay, so 20 into g plus a should be less than or equal to 25 g. G plus a should be less than or equal to 5 by 4 g. So a less than or equal to g by 4 means a cannot be greater than g by 4. Means g by 4 is the maximum acceleration. Okay, so the maximum acceleration with which the monkey can climb is g by 4, means 10 by 4, that is 2.5 meter second raised to minus 2. Okay, now children, we have another wonderful example, that is a monkey is descending from the branch of a tree with constant acceleration. If the braking strength is 75% of the weight of the monkey, the minimum acceleration with which the monkey can slide down without breaking the branch is. Okay, so the maximum tension that the branch can withstand is 3/4 of the weight of the monkey. That is 3 by 4 mg, that is F max. Okay, and the monkey is going down with an acceleration a. See, mass of the monkey is 20 kilogram, and see, the force is m into g minus a. It will be 20 into g is 10 minus a. Okay, when a equal to 10, when acceleration of the monkey is 10, the force on the branch will be 0. When acceleration is reduced to 9, the force on the branch will be 20. When the acceleration is again reduced by 1, means when acceleration is 8, the force will be 40. So when acceleration decreases, the force on the branch will increase. When acceleration is minimum, force will be maximum. Or when force is maximum, the corresponding acceleration is the minimum acceleration. Okay, so F max we have 3 by 4 mg, corresponding acceleration will be minimum acceleration with which the monkey can slip down. Okay, that we will get g by 4. Okay, this one. Now let's see the next question. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. Means body must be moving with the car with the same acceleration as that of the car. Then only it will appear stationary with respect to the car. The coefficient of static friction between the body and the floor is, see, the car is being directly driven by the engine. See, if the block also moves with the car with the same acceleration, the necessary force is being provided by the friction. But there is a maximum value for the frictional force that acts on the body. It is given by mu mg. This is the maximum available friction. And the force required to move the body is ma. Thing is that, see, this ma is the force that we require. And this is what we have. See, the quantity on the right side is what we have, and the quantity on the left side is what we needed. See, what we needed must be less than or equal to what we have. Okay, now let us see ma less than or equal to mu mg. So a, the acceleration with which the car is being driven, that must be less than or equal to mu g, means it cannot be greater than mu g. Means mu g is the maximum acceleration, mu is 0.15 and g is 10, so it will be 1.5 meter second raised minus 2. Now let's see the next. A conveyor belt is moving at a constant speed of 2 meter per second. A box is gently dropped on it. See, when the box is placed, its horizontal velocity is 0, and finally the horizontal velocity of the box will become equal to that of the conveyor belt. Okay, conveyor belt. So initial velocity of the box is 0 and final velocity is 2. Okay, so the average velocity will be 0 plus 2 divided by 2. See, average velocity is initial plus final by 2. That can be applied only when the acceleration is constant. Okay, here the belt is moving up, moving forward. When the block is kept over the belt, see, the block exerts a frictional force on the belt that will oppose the motion of the belt. So the friction acting on the belt will be backward. Then the reaction exerted by the belt on the block will be forward. That is equal to friction mu mg. And the block is being driven forward by this friction. It is a constant force. So the block experiences a constant acceleration. Then its average velocity will be the arithmetic mean of initial and final. Initially the horizontal velocity of the block is 0. Finally its horizontal velocity will become equal to that of the belt. That is 2 meter per second. So average velocity will be 0 plus 2 by 2. And the time required, okay, see, that is given by v equal to u plus at, final velocity 2, initial velocity 0, acceleration is mu g, acceleration due to friction. What is mu? That is 0.5, g is 10, so acceleration will be 5, and t we will get 2 by 5. Displacement is average velocity into time, okay, so that will be 2 by 5, and it is equal to 0.4 meter. So this is the displacement of the block over the belt. What is this? 100 Newton force acts horizontally on a block of mass 10 kilogram. Okay, rough surface, that's also fine. Coefficient of friction is 0.5. Acceleration due to gravity is taken to be 10 meter per second square. Okay, what we have to find out? The acceleration of the block. Okay, fine. Right, suppose this is being pushed, this is being pulled horizontally by a constant force of 100 Newton. Friction will be mu into normal reaction, that is 0.5 into 100, that is 50. So the resultant force will be applied force 100 minus friction, that is 50. Resultant force will be 50 and the mass is 10 kilogram. So the acceleration will be 5 meter per second square. So this is 5 meter per second square. See, heavy uniform chain lies on a horizontal tabletop. If the coefficient of friction between the chain and the table surface is 0.25, then the maximum fraction of the length of the chain that can hang over the edge of the table is. See here, suppose L is the total length and X is the length of the hanging part. It is a uniform chain. Mass per unit length, or we will call it linear mass density, suppose it is lambda, then the mass of the hanging part will be lambda into x. The weight of the hanging part will be lambda into x into g. Okay, that weight of the hanging part is the force which produces the motion, or the force which favors the motion. The force which opposes the motion will be the friction acting here. Okay, friction acting on the part of the chain that is over the table, right? Okay, what is the length of the chain over the table? That is L minus x. Mass per unit length is lambda. So the mass of the part of the chain that is on the table will be L minus x into lambda. Its weight will be L minus x into lambda into g. That weight is acting down. Normal reaction will be equal to that and it acts upwards. So the friction, maximum friction will be mu into normal reaction. So mu into L minus x into lambda g. Okay. This is the maximum friction. Mu into L minus x into lambda g. That should be greater than or equal to the driving force in order to keep the chain at rest. Okay. Greater than or equal to lambda xg. Lambda and g common on both sides, that we can cancel. So we will get L minus x by x greater than or equal to 1 by mu. Okay. So L by x minus 1 greater than or equal to 1 by mu. This minus 1 taken to the right. So it will be plus 1. So L by x greater than or equal to 1 by mu plus 1 or mu plus 1 over mu. Okay. And see, then x by L means it is inverted. X by L less than or equal to mu by mu plus 1. Okay. See, we have to find the percentage length that can be a maximum percentage of length that we can hang over the edge without sliding down. Means, see, the length of the hanging part divided by the total length will give you the fractional length of the hanging part. So this is the fractional length. Fractional length can be less than or equal to, means it cannot be greater than this. Or this is the maximum fractional length of the hanging part, maximum. Into 100 will give you the maximum percentage of the hanging part. Okay, here we have mu equal to 0.25 divided by 1 plus 0.25. That will be 25 over 125 equivalent to, so it will be 1 by 5. That is the maximum fractional length of the hanging part. Into 100 will give you the percentage length. That is 20%. Now let's go to the next question. Starting from rest, a body slides down a 45-degree inclined plane in twice the time it takes to slide down the same distance in the absence of friction. Okay, the coefficient of friction between the body and the inclined plane is. Okay, see, here we have got two cases. One is with friction and the other without friction. Okay, in both the cases, body starts from rest, okay, and it moves with a constant acceleration that is given by C A equals G sin theta minus mu cos theta. If there is no friction, you have to simply put mu equal to 0. Okay. Now in the first case, there is no friction. Body starts from here from rest and covers a displacement S. In the second case also, body starts from rest and covers the same distance S. Okay, now let us see S equal to ut plus half at square. See, in both the cases, body starts from rest, so we can write u equal to 0, ut 0. So S will be half at square, half at square. In both the cases, with the friction and without friction, the body has to move through the same displacements. So S is same in both the cases. Let's take the first case. Without friction. Suppose the time taken by the body to slide down the incline is t. Then half acceleration without friction you will get by putting mu equal to 0. Then it will be g sin theta and t square. In the second case, that is with the friction, displacement is same as before. and half. Acceleration is different, g sin theta minus mu cos theta, and time, say it is n times of that required in the absence of friction. N times of that required in the absence of friction. So the time will be nt. Here we require the square of the time, so it will be nt whole square. Okay. Now see, we have half on both the sides, t square also on both the sides, right? Now g is also there, g. Okay. Now see, there is n square on the right side. Take that n square to the left side, so it will be 1 by n square. Okay, on the left side there is a sin theta. If this sin theta is taken to the right, okay, sin theta minus cos theta whole divided by sin theta. So that sin theta is common to both these terms. So in the first term, sin theta by sin theta, it will be 1. And in the second term, mu cos theta by sin theta is cot theta. So it will be mu cot theta. Okay, let me take this minus mu cot theta to the left. So it will become plus mu cot theta. And when this 1 by n square is taken to the right, it will become 1 minus 1 by n square. Okay. Now mu will be, we have to take this cot theta to the right, so it will become 1 by cot theta and it is equal to tan theta. So if the time taken by the body to slide down a rough incline is n times of that required in the absence of friction, then the coefficient of friction is 1 minus 1 by n square times tan theta. Usually theta will be 45 degree. Okay, and tan 45 is 1. Okay. So you will get mu equal to 1 by 1 minus 1 by n square. Here n is given as n equal to 2. Okay, n equal to 2. See, the time required with the friction is twice of that in the absence of friction. Okay, so we will get mu equal to 1 minus 1 by 4, or it is 3 by 4, and it is equal to 0.75. So 0.75. Okay, now let's go to the next question. A point mass m is moved in a vertical circle of radius r with the help of a string. The velocity of the mass is root 7 gr. At the lowest point, the tension in the string at the lowest point is. Okay. See, the minimum velocity that must be given to the body at the lowest point of the circle, so as to complete the vertical circle, is root 5 gr. Root 5 gr. If the velocity given to the body at the lowest point is greater than or equal to root 5 gr, it will complete the vertical circle. Okay. Now see, if the body starts from the bottom with a velocity, say root 5 gr, okay, then it reaches the top with a velocity root gr. Okay, and velocity of the body when the string is horizontal will be root 3 gr. If it starts with the velocity root 5 gr. If the velocity at the lowest point is less than root 5 gr, it will not complete the circle. If it is equal to or more than root 5 gr, it will complete the circle. Okay, if the velocity at the lowest point is root 5 gr, then here it will be root gr, here it will be root 3 gr. If the velocity at the lowest point is more than root 5 gr, velocity here will be more than root gr, and velocity here will be more than root 3 gr. Okay. Now see the difference between these two. See, this is say velocity v1, and say this velocity is v2. Okay, so v1 square minus v2 square, this is equal to 4 gr. This is always true. It is unconditional. Whatever be the velocity at the lowest point and highest point, the difference will be always root 5 gr. And also see, the tension in the string will be maximum when it is at the lowest point and minimum when it is at the highest point. And the difference in maximum tension and minimum tension, okay, difference between the maximum tension and minimum tension is also unconditional, and it is always equal to 6 mg. Okay, v1 square minus v2 square always 4 gr. T max, maximum tension in the string minus minimum tension in the string, that is always 6 mg. Okay, see, for solving this question, we need not know all these things. Okay, just I have explained all these things. Now what we have to find out here, the tension in the string at the lowest points. Okay, let me tell you one thing regarding the tension in a string. See, that please listen. The tension in a string will be acting on all the bodies to which the string is attached. It is along the string and away from the body. Okay, it is along the string and away from the body. When the body is at the lowest point of the circle, so the tension will be along the string and away from this body. Means away from this body along the string means it must be upward. Any other force acting on the body? Definitely. The second force acting on it is weight, mg. Whenever a body is moving in a circle, there must be a resultant force directed towards the center. Then only the body can move in a circle if there is a force directed towards the center. Here we have two forces. One is acting towards the center and the other is away from the center. Resultant force must be towards the center. And that is T minus mg, resultant force T minus mg. That provides the centripetal force. Means it is equal to mv square by r. And here T equals mv square by r plus mg. We have root 7 gr. So v square will be 7 gr. And tension will be 8 mg. Okay, so here the answer will be 8 mg. Right? Now children, we have another wonderful question here. A block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis will be. Okay, see the block is here. As the cylinder rotates, the block will be moving in a circle. So there must be a resultant force acting on the block directed towards it, the center of the circle. Okay, here the block will be moving like this. So the resultant force must be towards the center. Here that force is the normal reaction exerted by the cylindrical wall. Okay. And now that is, that force, normal reaction is capital N. Then capital N provides the centripetal force. If it rotates with an angular velocity omega in a circle of radius r, that is equal to the radius of the cylinder, then the this centripetal force, it is provided by the normal reaction, that is equal to m omega square r. Okay. Now see, this body will have a tendency to slip down. It is being balanced by the friction, mu into normal reaction. Okay, that mu into normal reaction is the maximum friction. Okay, for the body to be in equilibrium along the vertical direction, this mu n should be greater than or equal to mg. Okay, so mu n, that is F max, should be greater than or equal to mg. Or this mu, this normal reaction can be replaced by m omega square r, should be greater than or equal to mg. And omega greater than or equal to root of g by mu r. Greater than or equal to means it cannot be less than this value. Cannot be less than this value. So this is the minimum. Okay, this is the minimum value. Okay, see the minimum angular velocity. Okay, so that we will get 10 radians per second. 10 radians per second. Now next, two stones of masses m and 2m. Okay, m and 2m we have. Whirled in vertical circles, the heavier one in radius r by 2, means 2m is moving in a circle of radius r by 2, while m is moving in a circle of radius r, right? The tangential speed of lighter stone is n times that of the value of the heavier stone. This is moving with a speed v, while this is moving with a speed nv. Okay, experience the same centripetal force. So mv square by r is the same for both the bodies. Okay, m speed is nv whole square divided by r. The other one is mass 2m, speed is v square and radius is r by 2. Okay, this is the centripetal force on first particle and this is the centripetal force on the second. So we will get n square equal to 4 and hence n equal to 2, right? That is a 500 kilogram car takes a round turn of radius 50 meter with a velocity 36 kilometer per hour and it is equivalent to 10 meter per second. Okay, we have to find the centripetal force, that is mv square by r. Mass we have 500 kilogram and velocity is 10 meter per second and radius is 50 meter. So it will be 1000 Newton. Okay, so 1000 Newton, right? A particle of mass m is moving in a horizontal circle of radius with a uniform speed v. When it moves from one point to a diametrically opposite point, okay, it is moving with the same speed v, so its kinetic energy changes mv square by 4. That is a wrong statement. Momentum does not change. Momentum being a vector, its direction is continuously changing. So momentum does not change means it is a wrong statement. Momentum changes by 2 mv, that is true. See, suppose the body moves from this point to diametrically opposite point here. So this is the final momentum and this is the initial momentum. These two linear momenta are in opposite direction. So if you choose this as positive, this should be negative. Change will be final minus initial. So mv minus mv, it will be 2 mv. Okay, so the momentum changes by 2 mv, that is true.